Valentin Bondarenko, March 23, 1961. Valentin Bondarenko was a 24-year-old Soviet cosmonaut in training, selected as part of the first group preparing for human spaceflight. He was participating in an isolation experiment inside a low-pressure chamber filled with oxygen-rich air. The test was designed to simulate the conditions of extended space missions, and Bondarenko had already spent 10 days alone inside the sealed environment. The atmosphere, while controlled, made the chamber extremely flammable. At the end of the experiment, Bondarenko removed medical sensors and cleaned his skin with alcohol-soaked cotton. He discarded the swab, which landed on a hot plate used for warming food. The cotton ignited instantly. Fire spread rapidly through the oxygen-rich chamber, engulfing the confined space. Due to pressure differences, the chamber could not be opened immediately. Technicians were forced to wait as the fire burned. Bondarenko suffered fatal injuries and died hours later in a Moscow hospital. His death was classified and hidden from the public for nearly 2 decades. The incident led to changes in training environments and materials, but his name remained erased from history until the 1980s. Bondarenko became the first human to die in a space-related training accident, a loss buried beneath secrecy and silence. Apollo 1. January 27, 1967. Inside Kennedy Space Center, the Apollo 1 crew, Virgil Gus Grissom, Ed White, and Roger Chaffee, prepared for a routine test of the command module on the launch pad. The cabin was sealed, pressurized with pure oxygen, surrounded by wiring, instruments, and a dense maze of systems designed to keep them alive in orbit. Outside, engineers monitored gauges and controls, unaware of the danger lurking in the capsule's environment. Every spark, every metal contact could ignite disaster. Tension was invisible but heavy, a quiet prelude to catastrophe. As the astronauts ran through final checks and confirmed communications with ground control, suddenly a small spark ignited a fire inside the oxygen-rich cabin. Flames spread faster than anyone could reach the hatch. The inward opening design prevented emergency access. Heat and smoke consumed the module, trapping the astronauts within moments. Despite frantic efforts by ground crews, there was no way to reach the men. By the time the fire was extinguished, Grissom, White, and Chaffee were dead. Investigations revealed electrical failures and design flaws in the cabin, including flammable materials and unsafe hatch mechanisms. Apollo 1 became a grim turning point, prompting months of redesign, changes in safety protocols, and a lasting reminder of the lethal hazards astronauts face even before leaving the ground. Soyuz 1. April 23, 1967. Cosmonaut Vladimir Komarov prepared for launch aboard Soyuz 1, fully aware of unresolved mechanical issues. Ground engineers had repeatedly warned of parachute malfunctions and control system failures, yet political pressure drove the mission forward. The rocket lifted smoothly and Komarov entered orbit. Systems repeatedly failed, forcing him to manually adjust orientation and compensate for thruster malfunctions. Each correction consumed his attention and energy, while the spacecraft's faults grew more pronounced. During re-entry, the main parachute failed. The backup became tangled, leaving the descent capsule to fall uncontrollably toward Earth. Ground crews could only track its trajectory, powerless to intervene. The capsule struck the ground with extreme force. Komarov was killed instantly. Recovery teams arrived to find the mangled spacecraft. Investigations confirmed mechanical failure compounded by human and organizational pressure. Soyuz 1 became one of the earliest examples of fatal risk in human spaceflight, illustrating the lethal consequences of engineering flaws combined with political urgency. Komarov's death shaped future spacecraft design, ensuring redundant systems and more cautious mission approvals. X-15 Flight 365-97. November 15, 1967. Test pilot Michael J. Adams climbed aboard the X-15 rocket plane, ascending to the edge of space for a research mission. The craft was built to collect data at extreme altitudes and speeds, pushing the boundaries of human flight. Adams executed launch procedures flawlessly, and the X-15 pierced the thin upper atmosphere, instruments recording every variable in a realm few humans had ever reached. Suddenly, instrument failures disrupted guidance. The aircraft entered a violent spin at high altitude, leaving Adams unable to regain control. The X-15 tumbled uncontrollably, descending toward Earth at more than 5 times the speed of sound. Recovery was impossible. Aerodynamic forces exceeded the pilot's capacity to correct the trajectory. Adams was killed on impact. Investigators determined the combination of mechanical failure, extreme velocity, and high-altitude environmental stresses caused the accident. The X-15 incident underscored the peril of experimental space-bound flight, influencing safety protocols and vehicle design. It remains a stark example of how human courage and experimental ambition collide with unforgiving physics at the edge of space. Soyuz 11, June 30th, 1971. Cosmonauts Georgy Dobrovolsky, Viktor Patsayev, and Vladislav Volkov concluded a 23-day mission aboard Salyut 1, the first space station. They had performed extensive scientific experiments and maintenance. Spirits were high as they secured equipment and sealed the capsule hatch for descent. The crew expected a routine return to Earth, unaware of the silent threat waiting in the tiny cabin. Moments after undocking, a ventilation valve opened prematurely, rapidly depressurizing the capsule. The cosmonauts were exposed to the vacuum of space. There was no time to react, and they perished instantly. The loss was invisible, occurring in the emptiness above Earth. Recovery teams located the capsule on the Kazakh steppe. Soyuz 11 remains the only human fatalities in space, outside Earth's atmosphere. The tragedy prompted immediate spacecraft redesign, including mandatory pressure suits during critical phases. The mission's scientific success was overshadowed by sudden, silent death, a grim reminder of the vulnerability of humans beyond the protective layers of the planet. Space Shuttle Challenger, January 28, 1986. Challenger waited on the launch pad at Kennedy Space Center with 7 astronauts aboard, including Krista McAuliffe, selected as the first teacher in space. Engineers had raised concerns about the solid rocket booster O-rings in cold temperatures, but management approved the launch. As the shuttle lifted into the sky at 11:38 a.m., it ascended smoothly, trailing white exhaust against a pale Florida horizon, the crew unaware that disaster had already begun. At 73 seconds, the O-ring failed, allowing hot gases to escape and weaken the external tank. An explosion erupted, tearing the shuttle apart in midair. Observers watched the vehicle disintegrate, plumes of smoke and debris scattering in every direction. There was no chance for the astronauts to survive. The destruction instantaneous and total. All 7 crew members perished. The nation watched in stunned silence, and investigations revealed a combination of engineering flaws, ignored warnings, and procedural oversights. Challenger's loss prompted a complete overhaul of NASA's design review and launch protocols, creating new safety standards that reshaped human spaceflight. The tragedy became an indelible moment in history, a sudden and public reminder of the risks of exploring beyond Earth. Space Shuttle Columbia, February 1st, 2003. Columbia had completed a 16-day mission of scientific experiments in orbit. During launch, foam insulation struck the left wing, leaving damage that went undetected. As the shuttle prepared for re-entry, the crew ran through standard procedures, unaware that the impact had compromised the thermal protection system. Atmospheric friction would soon test the craft's limits. Upon re-entry, superheated air breached the damaged wing. Structural failure quickly spread, destabilizing the shuttle. Columbia broke apart over Texas and Louisiana, scattering debris across hundreds of miles. Ground tracking observed fragments of the spacecraft tumbling uncontrollably. The crew had no time to respond. Survival was impossible. All 7 astronauts were killed. Recovery teams spent weeks collecting debris and reconstructing the sequence of events. Investigations confirmed that the foam strike initiated the catastrophic failure and exposed deficiencies in inspection and risk assessment. Columbia's destruction reshaped NASA's approach to safety, inspection, and re-entry procedures, leaving a lasting mark on spaceflight history and emphasizing the fragile boundary between survival and disaster.